Okay, class, today we are going to be graphing linear inequalities in two variables, which is section 6.7. So I'd like you to pause the video and fill out the two vocabularies in the space provided in your book. And then when you're done with that, you may resume the video. Okay, so here what we're going to do is we're going to tell whether the ordered pair is a solution of the inequality. So we have an x and y, so we're going to plug those in for x and y. So I have 3 times my x minus my y, and I want to know, is this bigger than or equal to 2? So 6 minus 3, is that bigger than or equal to 2? Yes. So it is a solution. So here we're also going to determine if it's a solution. So to determine if it's a solution, what we're going to do is we're going to again plug in x and y. So go ahead and pause the video and plug those in to check. Okay, so I plugged in my x and my y, and now I'm just going to simplify. -1 minus 4, and I want to know, is that less than 0? So -5 is less than 0. So since that's a true statement, yes, this is a solution to the inequality. Okay. Here what we're going to do is now we're actually going to graph those. So on number 3, we're going to graph this inequality. Okay, and I have the step-by-step procedure, and we're going to add in one extra step here, and that extra step that I'd like you to write in would be to write it in slope-intercept form. So you write your inequality, in slope-intercept form. So that's the first thing we're going to do. So we're going to put this into slope-intercept form, which means we're going to solve for y. So I'm going to subtract 3x from both sides, and I have minus y is bigger than or equal to negative 3x plus 2. And since I have a -1, I need to divide everything by -1. And since I divided by negative, I changed the direction of the inequality. And I have -3x over -1, which becomes positive 3x. And 2 divided by -1 becomes minus 2. So now I've rewritten my inequality. Okay, so step 1 says to graph the boundary line. And it says use a dashed line if it's less than or greater than, and use a solid line if it's greater than or equal to or less than or equal to. Okay, so let's do that. So -2 is our y-intercept, and our slope is 3. So we're going to start by graphing the y-intercept at y is -2. And our slope is 3, or 3 over 1. So we're going to go up 3 and over 1. And we're going to do this a couple times. Up 3 over 1, and likewise down 3 and left 1. So now I have my line, and I need to graph the boundary line. So since the inequality is greater than, it's greater than over here, so it's going to be a solid line. So I'm going to draw a solid line through here. So go ahead and use your ruler to draw a solid line. And there is my computer ruler that I drew in. So if it was less than or greater than, your line would be dashed like this versus solid. Okay, so that was step 1. Step 2 would be to test a point not on the line. So we want to do a point not on the line. So any point not on the line. So here at 0, 0 would be a good test point. So step 2, we're going to plug in 0, 0. So I'm going to plug in x is 0 and y is 0 into my original here. So 3 times 0 minus 0, is that bigger than or equal to 2? It's just like the first problems we did where we're testing it. So 0 minus 0, is 0 bigger than or equal to 2? No, that's false. So step 3 says shade the half plane. So we're either going to shade this half or the other half. And we're going to shade the half plane containing the point if the ordered pair is a solution to inequality, and shade the other half of the plane if the ordered pair is not a solution. So here we plugged in 0, 0, and if it is a solution, we shade towards 0, 0. And if it's not a solution, we shade the other way. So since this was a false statement, we're not shading towards it, we're shading away from it. So this is where highlighters is really handy. So if you have a highlighter, it's handy to pull out your highlighter so you can just easily shade that half plane. Okay, so let's go on to the next graphing example. Okay, so here we need to first solve for y. So I'm going to divide both sides by 3, and I get y is less than -3. So now I've written in slope-intercept form, and then I'm going to graph the boundary line. So y equals -3 is down here at -3. And then I want to graph y equals -3. Since it's less than, it's going to be a dashed line. So instead of a solid line, we're going to use our ruler to draw a dashed line here at -3. And remember, our lines have arrows on it. And we're going to pick a test point not on the line for our step 2. So any point not on the line. You could choose this point if you want. That's not on the line, but then you have to plug in that point. I'm going to pick 0, 0 because it's not on the line. So I'm going to test 0, 0. I'm going to plug in my x and my y into my original problem. And there is no x's to plug in, so that's okay. So I'm just going to plug in my y. So 3 times 0 is less than -9. Is 0 less than -9? Well, again, that's false. So since 0 is not less than -9, we're not going to shade towards it. We're going to shade away from it since it's false. So I'm going to shade below the line. So I'm going to shade down here. Now, since both of these ended up turning false, I'm going to show you what would happen if we chose a different point where it would be true. So you don't have to write this down. Okay, so I'm going to redo step 2, where I'm going to test, say, the point 1, -4. So if I plugged in that, I have my x and my y, and I know that point's not on the line because that point is over here. And so I'm going to plug in my y into my original, 3 times -4, and I want to know, is that less than -9? So 3 times -4 is -12. Is that less than -9? So that's true. So when your inequality statement is true, you're going to shade towards that point, which is why my shading includes that point. Okay, so let's move on to the next example. So the next example is a word problem. So go ahead and pause it and read your question and highlight or underline any important thing. Okay, so I went ahead and underlined the important things for here. So we have $20 for a pair of pants, and we're told that the number of pants we're going to buy is X, and $15 per shirt, and we're told that Y is going to be the number of shirts. And we have $125 to spend, not more. So we're going to write an inequality that describes the different number of pants and shirts that we can buy. So I know I have $20 per pair of pants plus $15 per shirt I'm going to buy, and all of that has to be less than or equal to $125. So I'm going to do 20 times my X for the number of pants and 15 times Y because that's per shirt, and those two summed together has to be less than or equal to how much money I have to spend, which is $125. And all we had to do for this is write the inequality, so we are done with that, and we can move on to the next question. So here we are translating sentences. It says the quotient of y and 2 is greater than the difference of 7 and x. Okay, so the quotient of y and 2, and then we have greater than, and we have difference of 7 and x. So we have 3 different things. So the quotient of y and 2, quotient means divide, so y over 2 is greater than. Doesn't say greater than or equal to, so I'm going to leave it as greater than. And difference means subtraction, 7 minus x. So we've translated the sentence, and that's all that we need to do. And then finally, on the last slide, you have the homework problems. So now what I would like you to do is do the homework problems, and then we will answer questions on any homework questions that you have in class tomorrow.